Hopefully, that is now live. I'm not quite sure. Hopefully, you can hear me. I had a little problem with the microphone there. Sorry about that. It's sort of a new setup for me, so I'm not quite sure. I've just watched the playback and you can see me making weird noises. Never mind. Anyhow, today, let's see what you can see on the screen because I don't really know. If you can't hear me, do let me know in the chat and then I will alter something. But fingers crossed, it's working. Let me just stop that. And where's my other window? Oh, we're looking at the wrong thing over here. And there. No, that's what I wanted to look at. And then that. Okay. So you can see what I can see, which is great. And so in the top corner on the that way, wherever that way is, you can see my multimeter. That is my Uni-T multimeter. I've got it hooked up as a, it's in current mode, so it's reading the current of the LEDs at the moment. And the current of the LEDs is 15 milliamps, and that's the board in, well, it's running but not outputting any light, which doesn't change much. You'll be surprised, I think. In fact, let's turn it into milliamps mode for a second so we can get a bit more resolution. In fact, 11 milliamps is the true value, but I've put it in amps mode. Do you know what? We'll leave it in milliamps mode. It's going to give me a different reading to the last time that I did this, but whatever, we might as well have a look. Where's the chat? Okay, it's not on the screen because it plays it back later now, so I've sort of decided to do that. Oh, so we've got quite a few people here. Hello. We've got Leonid, we've got UK Heli Bob, we've got Cider Master, Electron Ash. I'm going to go with Eden Flower. Dave Darko's here as well. Hello. So today, hang on. The important thing has to happen first. It's just juice. So today we're going to be testing some LEDs with the help of what you can see on the screen there, which is this little C-Tonic. In fact, you probably can't see it all that well, but it's a C-Tonic Lightmaster Pro. L478D is the model number, and that is a lux meter essentially. It can be used for lots of different applications, but in this application I'm just measuring the brightness of the LEDs, but it doesn't respond very well to LEDs, so I'm measuring a relative change rather than I am something exact, and I'm fine with that. I don't expect it to be perfect, so as long as it gives me a relative output, then I'm all right with that. Now, the process that I've got here is I've got a little, in fact, I can probably take this off without too much trouble and show you, hopefully. Let me just see if that's in focus or not. So yeah, you can see I've got my Arduino there, and it's on a breadboard with a button, which is just there. And then it's hooked up to this thing, which is on a sort of a jig. And that's one of these, except it's the other version. So this one that's on the jig, I can't unhook it now, but the one that's on the jig has, oh no, how am I going to get this back on? There we go. The one that's on the jig has the white LEDs. And so they're SK6812 LEDs, but they're white. So they have different flavors of white, different colors essentially. Just over the microphone there. This is called, oh, you can't see it, hang on. This is called Sadler's Hop Bomb, and it's completely non-alcoholic. American Pale Ale brewed with Amarillo and Citra hops. The sweet malty base is lifted by a powerful hop character. 4.6%. I can only assume that means air and not alcohol. because obviously I wouldn't do that. My hands are wet now, which is great for electronics. Anyway, we're going to get started. So I'm going to turn on this C-tonic thing. The reason I'm doing this tonight is because I actually only have this for one more evening. And then I have to take it back to the person I borrowed it from, because this thing's worth about £400 or something like that. So it's something I can't justify buying and wouldn't justify buying. So it's just for these tests. I've only tested one LED so far. Don't tell people that. I really should have put more effort in. Let's just move this. God, this microphone's on a lovely boom, look, actually. Oh, except it lifts out of there. So I can lift it up really high so I can reach under and then just move that around a little bit. That's better. Let's see, how does this thing work? There we go. That's better. I'm just tying that up a bit. And I can reach under it, which is brilliant because it's raised up. Anyway, let's just play that. Click on the thingy. Anyway, this meter, it's a touch screen meter, which is really awesome, but what does that button do? Oh, not what I want it to do. I wanted it to take the reading, but it doesn't do that. What if I press the screen? No. So there's a button on the side here which takes a new reading. And so I've got my baseline reading there. The LEDs aren't on and I'm getting 60 lux. So on my spreadsheet behind here, in fact, shall I zoom in on that a bit? How do I make that bigger? Control plus. That'll do. It makes everything bigger, but that's all right. So this is just a Google sheet, and I've set it up with a few little equations to figure out what the change is, the lux increase. So at 0, we're looking at 0.11. In fact, I'm going to put it back onto the amps range because the reason I had it on there was because it has the milliamps range and the amps range have a different burden voltage. And so I've decided it's just going to be the amps range because it has the least burden voltage. And so we're going to be measuring that. So I'm going to say it's 15 milliamps, even though it's not, because it is measuring 12 milliamps NY power supply. But we're going to, do you know what? Let's go with milliamps. It's not going to go up that much. It's reading 11. The other one's 12 versus 15. It's less. So 0.012 is my current reading. Lux is at 0. The baseline lux is 60. And the lux increase is 0. And we've got no calculation for that, but I do on the next one. So cumulative lux is also a calculation, but that doesn't need to be there. Lux increase, linear lux increase. Oh, we calculate that later. So the idea is if I jump to one that I've already filled in, so you'll notice at the bottom these are called star 0, count 0. Now this is just the way that it's done in the Arduino sketch that I'm using. So if I jump to that, and you can see that we've got set pixel color. I'm just using the NeoPixel library from Adafruit, and so we're setting this pixel color, the one in the middle, because these are sort of like the RGB NeoPixels, except for they're white, white, white rather than RGB. So I've already filled this one out. So there are some graphs in here looking at the 8-bit brightness versus the lux increase. And I'm trying to see if there are any kind of sweet spots, any kind of Goldilocks zones where you're getting a higher increase in lux versus the amount of current that you're bunging into it. And so far, it's fairly linear. I mean, this display here isn't actually very linear. You can see that the increase in lux is greater the more current that you put into it. So at the lower levels, you're not getting a massive increase in current, but then it starts to widen as we go further up the scale. So past around, 130, we're starting to get a larger increase for each step. But as you'll see, the steps take a while to give us a lux increase. And that's partly due to the resolution of this lux meter, but also I think it probably is the case that it's not quite like that. There's a bit more deviation. We also have one that uses sort of a log scale, and that doesn't really tell me much. And there's another graph here somewhere, I think. Not that I can see it right now. Oh yeah, here's another one. So this is the cumulative lux increase versus a linear lux increase. So if the lux was increasing at a linear rate, can you see all of that? Let me just jump up to this thing. So yeah, if it was increasing at a linear rate, the red line is what I would expect to see. And I can see some deviation here, but it's largely linear, which is incredibly disappointing, but it isn't entirely unexpected. But I don't expect that to be the case for all of the LEDs. I think there will be some deviation. And if I look at current versus the linear lux increase, so this is the linear lux increase across the graph. You can tell that because it's just going straight up like that. And this is the current. So we're shoving more current in for that lux increase at the lower end here. So actually we're getting more performance out of it at the higher levels. And we're not actually bunging in more current. So the ratio is different here. I don't know how to work out this area ratio. So if someone's really clever, they'll be able to figure it out. I can see somebody clever has just popped in. Hello, Julian. We've got some other people that popped in as well. So we've got Chris Cochran, hello. Brian's here, hello. Gary Rivet, Stephen Birch, Yorick, and that's it. I'm all caught up. So essentially, we're going to be filling out some new graphs. Really a little bit boring probably, but we're going to start over here on this one. So we've got 11 milliamps coming in on the current display. You can see it as well as this happens. And now I'm going to turn this meter back on because I've been rabbiting on enough. So 60 lux is our baseline reading. I press the button and hopefully you'll be able to... I don't think you can see it. Let's see if I can angle this a bit better. Oh, hang on. Let's move it over a touch more. Then you can sort of see the reflection of the LEDs. Oh no, I'll have to reach around that thing then. Well, maybe you can tell anyway. It's fine. Is it possible to do that? Yeah, you can kind of see them there. You'll just have to put up with the webcam wobbling a bit as I increase it. So if I go to press the thingy again, we've got 65 lux. I'm going to press it a couple more times just because this thing's a bit funny. But no, I can't do that with the webcam there. You're just going to have to believe me when I say that the LEDs are increasing. So 70, 70. Try not to move this very much. So on the very first step, we're at 70. Let me just make sure I'm not increasing steps unnecessarily. I can tell that because I have a count on here. So in fact, we can't really leave that on the screen, but we're on 1. So if I press, hang on, we're on 0. That's not, oh, did I reset it because I opened up the serial? Hang on. So if I press it, we get 1 appearing here. If I press it again, it's debounced. So we can see that the current is increasing, and you can see that the lux increases. So if I press the button here again, you can see that it's on 230. But let's reset back down to 0, and then we'll jump back down to our baseline, which is 60. So we'll go up to 1. Our baseline was 60. We've got a lux of 70. So our lux increase should be C3 minus C2. Cumulative lux. Linear current increase, lux increase should be C3 minus C2. Hang on, I've made a mistake somewhere here. Let me just jump back to my thing. So 86. The lux increase should be C5 minus C4. Baseline lux. Oh yeah, sorry. Oops. Undo what I've just done there. I've just realized. So the lux is 70 here, which makes my lux increase Oh no, lux 60. So it makes my lux increase 10. That makes more sense. Oh, we've got Michael Bernhardt here. Bernhard. I don't know how to say that exactly. I'm going to give it a go. Oh, Julian, that's very kind. We've got Death Shaker here as well. Andreas? I don't know what I'm going to say there, sorry. And John Robinson's here as well. So at brightness level 1, we're currently drawing like that, 0.012. We're going to step up. I'm going to try and increase the frequency at which I do this. So this one's increasing fairly quickly. The previous one increased kind of slowly. So just double check that. 75 still, that's good. But we're still at 0.012, but we've increased by 5 lux, which is nice. So lux increase was 10, 5. So we've got half there. So that's all right. And then we'll go up again. Now, I did consider doing this in steps of 5, just because it takes a while. So I wasn't really sure I wanted to do it, but we're at 0.013 and we're at 86. Next step, 90, 0.013 and 90. I have, I think I put an end on this stream at like 10 something, but I've only got 2 of these, so it will be as long as it takes to get through those 2. So just check where we are now, because I'm getting confused. We're on 4, so let's go to 5. That's 100, press it again, 100. So this one is going up much quicker than the previous one. 13. But it may bottom out and just not have a greater increase later on. So 0.014 and 110. It was 1.4 when I looked at the meter. So if it changes after I've done that, then I'm not going to worry about it too much. So again, we're at 0.015 and the lux meter is reading 110. So we know that it's got a resolution that's not just 5 and 10, because we got one that says 86. So I'm going to sort of trust the meter, but we've gone up by a milliamp and we haven't seen a lux increase. So it's an odd thing, this weird relationship that it has with current. I think LEDs perhaps are a bit strange in that way. I'm just going to, if anyone has anything to say to me, because I'm going to be looking at this silly graph or the silly spreadsheet for a while, just put my name in the thing and it should highlight for me. So where are we at? We're at number 8. God, this is going to take a while, isn't it? We're at 15, 0.05. And we're at 120. So you can already see that the graph is filling itself out as I go, which is nice. But the linear lux increase is something that I have to do later on. So that's assuming that it has a linear increase from 0 to 255 across that 8-bit increase that the PWM on these LEDs have. So they're constant current. So essentially it's running this current constantly across this 8-bit range that it has, but it doesn't mean it's constant brightness. So that's what I'm measuring essentially. So we want 9, which is 0.016. In fact, I could bring that up on the screen so that I can see it all the time. That'd be helpful. And we've got 130. Next up, imagine that it would be 10, 140, and 0.016 still. So we're talking like half a milliamp change here if it's not demonstrating. So we're on 11, so 0.017 and 150. So this one is increasing massively. They're a lot brighter, it seems, than the previous one. So the previous one, let's get rid of these graphs here. We were down to, oh no, actually, I guess that's kind of the same, isn't it? We're down to, actually, no, the other one increased brightness. Oh no, if you take the difference, so it's 140 at 10, the other one. If you look at the baseline lux, or was it 80? Baseline lux increase, cumulative lux increase was 80 by that point. And the cumulative lux increase at this point is also 80. Okay, so I'm not demonstrating anything in particular there. It turns out it's basically the same. So next one, 160. If this turns out to be entirely linear and I've wasted my time, I'm not going to be entirely pleased. My day was great, actually, Julian. I've been to work today and it was okay. I survived. How was your day? John Robinson says, what beer are you drinking? This is a completely non-alcoholic, perfectly innocent beer called Sadler's Hop Bomb. Don't know if you can see it. Is that there? And it's very nice. It's a lot more hoppy than you would get a normal beer, because I think they just sort of blend up hops and throw them all in there, whereas normally you just soak the hops, I think. God, I'm getting distracted. This is going to take... Do you know, I did this the other day. I did one of these LEDs and it took ages. So what were we on? 12. Okay. So we're on 160 still. And the current has not increased. Why have I got my probes the wrong way around? I haven't. Why does it say minus? They're on the right. Hang on a minute. Current's going through here from the capacitor. Or maybe it should be before the capacitor. Oh, whatever. It's fine. Tabletronics or Tabletronics says, are these 6812s? Yes, they are. These are SK6812s. These are the white version. Electron Ash says, is the Lux info and binning, I'm not sure what binning means, not in the datasheet. If you can find me an SK6812 datasheet that has any information like that, I would be surprised. I did search and I couldn't find it. And I looked on the web to see if anyone else knew this information about these ICs, and particular LEDs. Plus, I think they probably vary from manufacturer to manufacturer, but I haven't seen anything. So if someone's got it, then please do let me know. So we're on 1314 is next. 170 and 0.019. Just in case anyone's wondering, this isn't entirely scientific, but it's about as scientific as I get with anything. There's going to be inaccuracies in my meter. There's going to be inaccuracies in the lux. And, you know, a lux meter doesn't really respond well to all waveforms of light. So these LEDs, for example, especially when I get around to doing the RGB ones, they're not really going to respond in the same way. So we're now on number 16 and we're on 0.020 and we're at 180 still. Not 180 hash, that would be incorrect. Next step. Leonard says, is row 14 and 15 the same? Nope, they are not the same. We've got 170 and 180, but the current was exactly the same at the time. as it is for 17, it's 0.02. So it's possible at times they're going to increase by sort of half a milliamp maybe. But that is what my meter's reading, so that's what I'm going to go for. It's the only measurement I can make, really. Incidentally, I'll make all these spreadsheets available if people want them. I don't know how useful they are or if people will trust the results. But that is partly why I'm streaming it, so you guys can see the effort that I put into recording all of these terrible results. What were you trying to post, Tabletronics? Maybe you can give me some clues and I'll do a little Google search or something. Julian's asked, what's this for? Well, I'm making a large LED matrix, a SK68121 one. Sorry, Leonid, what are you saying? 12 and 13, brightness 8-bit column. 12 and 13. Are they the same? 12 to 13? Oh, sorry. Yeah, they were the same, it seems. Oh, God, I've ruined it. I can go back and reset the microcontroller, check again, but I'm fairly sure it was accurate. We will see duplicates of these results, just like we see duplicates here of the lux value. Yeah, I'm making an LED matrix, and just out of interest, I was looking for some data on, you know, what kind of brightness can I expect at whatever current, you know, and I wanted to see, you know, where do I get the best value for current, essentially, in terms of brightness. And would that change dependent on, you know, if it was the green LED or the blue LED or the red one or the different whites? Because I bought these LEDs, which were RGB white, so they have 4 elements in there. And I thought, well, how much current is that white one going to draw? Because it looks a lot larger. And so I thought I'd investigate. In fact, can I put this under the... Let's see if I can put it under the little webcam. And it won't really focus, but you can see that there's a yellow portion there, and that is the white LED. And then there's the normal RGB section. And so I thought, well, it can't possibly draw the same current. It's taking up half of the chip. It must draw something different. So I wanted to check that. But I've started with the white LED because I thought it might be easier for this lux meter to read. So we're still on 210 and our current is 0.022. I've put a blooming extra value in there because of my fat finger typing. Oh, so I can select... No, I can't see a link if I click live chat. Second link. Right, I'm going to have a... I will look it up. Hang on a second. Oh, well, that is one of them. It's not the white though, or the RGB white. So I don't know who makes that one, but I'm going to guess they're going to be different. So we've got Relative luminous flux versus forward current. It doesn't have it sort of mapped out with the 0 to 255 though, which is annoying. It just says forward current. So you've got to assume that, what that current's going to be at that point. So you don't know where along that 8-bit path it is, I guess. I can send you I'll pop the link in. This is the one I think that it means. Julian can post links. He's a mod, and there's probably another mod in here somewhere. Sam says, why do you not do any 3D printing anymore? I do 3D printing all the time. You just don't get to see it very much. There's some 3D printing right here. There's this thing, which is part of my crap clock. So that's 3D printed. You'll get to see it eventually when it's finished, but I'm not prepared to give it out until it's done. All right, see you later, John. Okay, so let's carry on. God, I'm getting distracted. I've done 21 in like 20 minutes. Okay, next one. 230, so that's a large increase. And we're at 0.022. So we've got a large increase, but not much current increase there. So it isn't entirely linear. It's quite blocky, but I guess it would be for 8-bit, wouldn't it? Is it the next? Do I go? 21, yeah. .240, 0.023, 240. Do you know what, Julian? Someone's mentioning the pick stuff. I think. Hang on a minute. Let's see. Is that it? Oh, look, there's one of them. It's somewhere, but I picked up a pick. I've got the programming cable here. I don't know where the pick is because I haven't even tried it yet. But I had intended to roll your wheels on. Had intended to follow some of your tutorials and program up a pick. I didn't quite get round to it though, unfortunately. Life got in the way a little. So we're at 22, so I need to go next. So we're at 240 still. So it seems to be going up in sort of slower increments. 0.023. Next one. 260. 0.024. Next one. Electron Ash, you can go for your life. In fact, you can post what you like. Just be nice. Right, 25, we're on 0.025. And the current, the lux is 260. Next one. I had considered trying to write a program that would do this at like 5-second steps, and I would just have to be really quick, press the button, and write it down or whatever. But I found that, God, it was too tough. It was like having a job. So I soon gave up on that idea. Oop. 280. Next one. Still 280. We're at 0.026. Incidentally, I had some filters on my microphone the last time that I played around on stream with it, and for some reason it made my voice warble on the previous stream that I watched, so I took them off. So hopefully you aren't getting loads of clipping or me sounding weird or a lot of background sound, because I didn't know how to stop it doing that. Brian says, is there any way to interface with the Lux meter? Well, that's why I borrowed this really expensive one, because I thought there might be a way of plugging it into the computer. But sadly, there isn't. It does have a USB cable, but it's for charging, I think. And it can record data onto the... Oh, no, it's to... Yeah, so you can record 10 values onto the Lux meter, I think, and then pull those values off and import some not settings exactly, but profiles for it to use. So it's essentially, it's a photographic Lux meter. It's not really meant for this kind of thing, so you can't, unfortunately. What value are we on? 29. So we're on 0.027. And I could get the multimeter to record its bit, but there's no real point if I'm doing this manually anyhow. So 300, and we're at 0.027. It doesn't take forever. It just takes about an hour to do each one. Doesn't take forever. And there are 3 sections in this one and then 4 sections on the other one. So yeah, it's going to take a while. And probably reveal nothing, but I guess I'll learn how to make a graph in Google Sheets, I suppose. There is that. Incidentally, Brian has had himself a little bit of a viral hit. Am I on the right one? Yeah. So if you guys haven't had a look at Brian's channel, then he's recently been doing some stuff with a massive 32 by 64 pixel display. Is that right? And that's gaining some traction because it's very cool. So do head over there and have a look. We're still on 320, and it was 34, wasn't it? 34. This is the multimeter's jumping from 29 to 30 a little bit. It's on the cusp. But I'm still going with 0.029 and 320. One more step. And jumped up to 0.030, so 30 milliamps and 340. So you can see this graph is starting to take shape now. It's a little bit wobbly, but I think I really hope it isn't just linear. It's going to really bug me. It's just only 226 measurements to go. Great. Oh, Nefis is here. Hello, mate. And I'm sorry, Spanish LED guy, basically. That's all I think it is. Sorry, Proyectos LED. I subscribe to you on YouTube, but I have no idea how to say your name, so hello. Don't you dare hope it's linear, Julian. It better not be. Right, where are we at? If it is, then fine. I'll have discovered that it's linear, and that's not bad, and at least everyone else will know it's linear. But it doesn't appear, I don't know, it doesn't make sense for it to be completely linear. LEDs aren't linear. Like these, the ones on this, oh, let's just take this off. The ones on my binary binary crack clock don't have linear brightness. These will light up at sort of 0.5 milliamp, even less than that, much less than that. They will have some brightness, and then So you get this brightness in the beginning, but it takes a little while to get really, really bright. So it's definitely not linear. But maybe it is in these. God knows. Yeah, Leonard says I should have done the measurements every 5 or 10 steps. Maybe I should. I think the L in lux is part of luminosity, hopefully. Don't say that. 36. So we are on 36. Okay, so 0.030 and we're at 340. Next up. I don't know if you can see the not the multimeter, the lux meter, but it did say 370, 340. So that's why I press it a few times, because it doesn't seem to make up its mind, but it seems like it prefers 340. Now, part of this is because I press it a few times because these LEDs are PWMing. So they're turning on and off really quickly. So if the C-tonic happens to catch it on like the rising or falling edge or whatever it might have, any equivalent of an LED, but also the same as the light that's in my room, if it catches it at a weird flicker point, then maybe it's going to have a different reading. I don't know what the shutter speed is essentially of the lux meter, so I pressed it a few times and hope that that's adequate. So we're on 0.031 and oh god, what was the number? 340. So when it says 340 or it says the same value for a while, I know it's going to jump up. So it's 320, 340. We're going to see a jump on this one, I think. So currently on 37. So I think we'll probably see 20, so 360, maybe 370. Yeah, we've got a stable 370 there. It's not changing, so it's jumped up to 370. 0.032 and 370. So the previous increases have been around 20. We can see this from the lux increase column here. They've been around 20, and this is the first one that's jumped up to 30. So that increase in current is increasing the lux increase as well. So, and by a fairly large margin, but our current has also increased as well. So we need to sort of bear that in mind. But that's what I'm going to be using these graphs for, to seeing where the best value for current is, I guess. So next step, we're on 370 still, and it's 0.032. And then, of course, I'll overlay the graphs so you can see where they all intersect in terms of current. Toby says, hello David, you could have used the BH1750 FVI based lux meter module, attach it to Arduino, and then you could send the lux values over the serial port to your PC. Toby, just leave. I hate you. No, that actually sounds like a good idea. However, this is what I had available, so this is what we're using. Well, it's not what I had available. There were some other versions that I could have borrowed, but I've chosen this one. But there were none that could connect to anything, so I've just chosen this one, and it's a cheap setup. I can put it in the same place. It's fine. It's all right. I don't mind going through the hassle of doing it. It's almost relaxing. Julian says, how are you controlling current? Well, the NeoPixels have their own current control, but I've got an Arduino Uno here, which is feeding it that data. So it's saying it's got an 8-bit value. You can say 0 to 255 increase in current. It says increase in brightness, but it isn't going to be, I wouldn't imagine it's a linear increase because there's no way of it measuring its own increase in brightness. But it's certainly an increase in the PWM. So it's increasing current, the average current over that. And so I've got my 10 power supply of my multimeter is currently reading 32 milliamps, but actually the reading is 40 on the power supply. So if I jump it into amps mode, let's see if it changes. Yeah, amps mode has a lower forward voltage, burden voltage. So it's reading 43 now, because on the milliamps range, the higher stuff you draw, the more that burden voltage comes into play. But we're going to stay with the milliamps range because that's what we started measuring. So we're looking at the increase rather than the actual specific values. So we're looking at the changes rather than anything else. So it doesn't particularly matter that it's not displaying correctly. It's still getting the right. I'm still getting the right change values, is what I'm saying. So where are we at now? What number? 39. So next one. $370 still, and we're at 0.033. Oops, 370. Rumor has it you can update Google Sheets directly from an ESP8266 using Google Sheets. Oh yeah, okay. What? Can you do that? What have I done? Well, you can, and I can tell you how you could do that. Simply like a web scrape thing, but you could you can set up a form on Google Sheets and submit that remotely and have that add a value each time. That's really simple to do. In fact, you're going to create a form up in Tools, you can do that. You can also use the script editor to mess around with stuff and send you an email and whatever when something gets added. So, or when something's above a certain value. There's loads of cool stuff you can do in the script editor. I use Google Sheets a lot of work. Right, what are we on? 41. Okay. Incidentally, I was doing this and I went off somewhere, left it at full brightness, and I ruined one of my boards. There's just one LED that's got the red LED comes on, and it's shorted power to ground. I don't know how it happened, but it burnt itself out. So we're on 0.033. I'm just going to jump back to this anytime. And we're at 400. Hey, Emily. Haven't seen you for a long time. Well, Jeff says, it's PWM, so it should be linear. That's because duty cycle is linear. That's very true. The current increase should be relatively linear, but I don't think the brightness should be particularly linear. I think. I don't know. That's why I want to check. I mean, it doesn't... I know that LEDs don't have linear brightness when you change them with a resistor value or something like that. And there are gains to be made if you are happy with certain levels of brightness. So that's what I want to look at. But I'm fairly sure it's not completely linear. But it's probably quite close to being linear. So we'll see. So 0.034, and we're still at 400. But again, like I said before, this could be completely pointless. But that doesn't mean it's not worth doing just for a laugh. .034. Is it 3.4 still? 3.5. And 420. It's certainly, the results I've seen so far aren't linear in the way, they're not non-linear in the way that I want them to be. I want it to show that, oh, look, if you use really low current, then you get the most out of these LEDs. But what I'm actually seeing is if you pump more current in, you get greater gains in terms of brightness. That's not right. 0.035. It's bouncing around a bit, but I'm going with the lower value. 4.5, 4.6. I'm surprised a lot of you are hanging around for this. So I don't think I've got a massive range of things to talk about. Oh, I mean, I could tell you about... Julian did a video recently. What was it? Stuff you bought from Wilco. I don't know if it had a title, but you want to look at the graph again for the previous one or this one. Hang on. What's the thingy for this one before I get distracted? 420. So the 8-bit brightness versus lux at the moment looks like this. But for the previous one, the one that's done, these are the graphs. So, whoops. So this is 8-bit brightness. So this is a line just up to 255, and this is the lux value going up. And you can see that there's a gap here. So it's not linear, but it's slightly out of linear, but it's very close, isn't it? So that's what the current, so this is current versus the linear current increase. So if it was a linear current increase, so from 0 to the 0.99, there's a slight gap. If you discount the value where we've got this slight blip here where we've got the sort of quiescent current of the thing, then it's very slight. It's not an awful lot, but certainly the lux increase at lower currents isn't as high as the lux increase at higher currents. But it's not, at the moment, my testing doesn't show me it's anything to worry about, but it's literally minor little changes. But I will persevere and see what else I can find. But yes, what was I saying? Your video about the stuff you bought from Wilco. Well, I dug out my old atomic clock thing, the MSF receiver, because I was going to throw it in that VFD shield that I got from Elector. And what I did end up buying at the same time was this, which is a little atomic clock thing. And I'm taking it apart and I wanted to see what module was inside it. This was £2.50 for one of these atomic clock receivers. Atomic clock. I really should stop saying that. It's one of these MSF receivers. However, this one is also DCF77. Is that what it is? Something like that. It picks up the German one and the Japanese one as well. And I think there's a US one, is there? But it's like a multi-country receiver. But these screws are stuck in, so I haven't been able to take that bit out yet. But I've pulled the board apart and found that, how many crystals? I can see, sort of. So there are 3 different crystals in here to respond to 3 different frequencies. So I'm going to see if I can take it apart and make use of these using the standard code that's available for the DCF77. It's just DC77 and the MSF one. So I'll sort of give it a go. We can receive the German one here as well as we can the MSF one. So I will try it out. But I've been playing around with my old MSF receiver because of your video, and you pointed out that you'd picked up one of those clocks. And I thought, I'm going to play with that to see what I can do. And this thing, only £2.50, is pretty incredible. So I'll put a video up this weekend and I'll put a link. But it was Amazon delivered, I think. Oh no, was it Amazon or was it eBay? I don't know. I'll let you know at the weekend. I think it might have been eBay. Idiot. Oh, hit the mic. Well done, David. So at 420. I thought it might sound a little bit like reading out the bingo or something. 4 and 8, 48. I don't know all the funny ones actually. So 450 is our reading now. Does anyone know any funny bingo calls for any numbers that are coming up? That would be good. And what's our current? 0.037. That's a fair old jump. From 32 to 37. 3736. 37. Okay. Anyone else notice that? Or because I wasn't paying attention at the time. I bought two, Julian. Two of those clocks. I'd missed out on the chat now because I was chatting. I don't know if anyone said anything to me. Sorry, I've missed it. You might have to say something again. So we're on 48, 49. Did anyone else notice that? I mean, you can jump back in the stream. I can't, but and let me know whether that was a big jump. 5 milliamp jump. It's quite big. 450. And we're on 0.038. Next one. I'm just going to have to start going a little bit quicker on these. 0.038, 450. Next one. Still 450, 0.039. I'm not really sure this is my bag, to be honest, doing little scientific investigation. I think I'm a little bit more on the comedic side of electronics. That says 500, doesn't it? Let's try that again. Yep, I'm being very careful not to move this lux meter because I know that the angle and area all have an effect, which is why it's in that sort of vice thing. Why it's all sort of in that vice and then hooked or pointing directly at the thing. So it was 36, then 32, then 37. Oh god. Okay. All right. I'll do it again. Let's reset the microcontroller. Lights will go out. What are we going to? We're going to 47. If I hold it down, is that going to do it? No, because I've debounced the blooming button, haven't I? Idiot. So, 47 is 37. You're right. So did I just mistype? And the lux is 420. So it's maintaining. You're right. I must have mistyped that. So we want to go to 53. I was lucky you were here. I would have rechecked that probably before drawing any massive conclusions about the result. 500. .04, 500. 0.041, 500. 0.041, 520. Electron Ash has asked, which multimeter is that hooked up to? It is hooked up to a Unity UT61E, my favorite multimeter. And it has a sort of serial connection to the computer, which is nice. And the battery lasts forever, it seems. It never seems to run out. I think I've replaced the battery once in about 4 years, maybe more than that. So what current are we at now? 0.042, and we're still at 520. No, it's in the amps. Sorry, I should read out what I'm saying. Jeff says the multimeter is in the milliamps. The meter says milliamps, and the reading is 0.039. Is that microamps? No, it's it's in the amps range. So sorry, it's in the milliamps range. So it is. If I jump to the amps range, it should change on the screen. Let's see. Where's the window gone? Yeah, there you go. So I'm recording it as amps, but it's actually milliamps. So I'll put it back in the milliamps range. Again, the weird thing about burden voltage is it messes up with your current readings, but I'm not looking at the current per se. I'm just looking at the change. So it should be the same. I mean, the amps range is different from my power supply. And so is the milliamps range different from my power supply. So it's immaterial, really, the difference that's going on there. It isn't microamps, no. It is reading in milliamps, but it just says 0.02. That's just the way the meter works. So what are we on now? 58, and we're at 0.042. I started off with 0.042 or 0.0 because I thought the current would be much larger. I don't know. I didn't really calculate it, but I just thought it would jump up into the hundreds of milliamps range a lot quicker. But I sort of, because I did my initial calculations on all of the LEDs being on at once, but then I realized actually LEDs probably behave in a different way. So I don't want to measure them all at once. 58, 59. So yeah, the Steve has said something about MSF things. What did you say? Those MSF clocks don't get great reviews on Amazon. Perhaps that's why they're so cheap. Yeah, it's entirely possible, but we'll find out. I will thoroughly test it and make sure that it works. My MSF receiver over here is working. So that's the one I'm going to use in the clock. So I'm not really worried if I bought a cheap clock and it doesn't work very well. We'll see. Where are we at? 59. And we're at 520. And 0.043. So next, 0.043 still, 44, 43, it's jumping. I will always go with the lower value. Yep, I'm going to go with the lower value and it's 520. If it's jumping around, there's not much you can do apart from go for the lower value, unless you're trying to overestimate something. And that's where it changed. So 0.044. And we're at 560. Oh, is Sion doing a stream? He won't be online now, will he? Well, you guys can go over there. He's a lovely man. Literally, I'm recording numbers and pressing a button. It's like you're basically watching the most boring part of Lost. That's what you're watching. So if you want to go over and see Sion, because he's a nice chap, then you should. I will not stand in your way. And if I weren't streaming right now, I would watch Sion too, because I think he's a nice guy. But I do want to get at least one more of these done before I have to take this back and then borrow it again at some point to try and finish this off. If I ever do, if this one looks linear, then I'm going to assume that the other white LED is fairly linear. Or I'm going to think, well, actually those gains aren't as big as I hoped. So if that's the case, then I'll not worry about it anymore. But I did hope that there would be some kind of, like secret thing about it. But I guess there isn't so far. Nothing really obvious anyway. 0.045, 560. I will I'll do a little video like putting all this stuff together and saying, what a waste of time it was, or not. Or, oh, I've learned about, what number are we on? Learned about lux meters and how they don't really measure LEDs very well. Or this is how you do nice graphs in Google Sheets, maybe. Did any of you guys watch the Lazy Sunday video I put out the other day? It was a mammoth session, so I don't blame you if you haven't actually watched it yet, because boy, oh boy, that was probably one of the longest recording sessions that I've ever done. And it was probably made more difficult by the fact that I was trying to record the whole thing the whole time. I probably should have read the instructions as well. I don't know if you can hear me whispering on this microphone. All right, 600. We're still on 67. God, this is taking a while. Anyway, I hope you enjoyed it if you watched it. And Electors seem really, really nice. And also the kits are pretty high quality. You know, you've got to pay for that though. So essentially, it's not cheap. So you've got to sort of weigh that against it. But the magazine, I think there's a free digital version that you can get. So well worth picking up. Still on 600, 0.049. Stephen Birch made a Z80 MSF clock. That is outrageously cool. I've got a Z80. I was talking to Julian about this. I've got this Z80 and I don't know, it's probably like... Julian would know. I think is it like a PIO or something like that? I don't know. I've got various chips for this Z80 thing, and I was going to try and build my own based on this. I've got this massive bag of old chips, and I said I was going to sort them all out. I haven't quite sorted them all out, and so I got this Z80 and I thought, God, I could make a blooming computer with that. That'd be amazing. And then I realized what goes into it all, and I sort of put it off for a bit because Julian was building something, so I thought I could copy him. It's fine. But that's very cool, Stephen. I'm just reading chat and drinking a little bit of beer. I mean, I've done a whole 70, not even very many, is it? So I'll just wait. Oh, Simon enjoyed the Lazy Sunday. Good, I'm glad. And Jeff did too, I'm glad. Oh God, if Brian starts streaming too, there'll be no one here. Look, 5 people have already left to go and watch Sion's stream. But that's fine, you're just watching me fill in a spreadsheet. It's hardly the most exciting thing. But it does give you guys a chance to sit and chat to each other for a while as well. So we're at 640 now and 0.049. 50, 49, 50. What am I going to choose? Well, it's hanging on 50 longer than it is 49, so we're going for that. 640. Right, next one. 0.050. 640. 0.051. 640. I'm going to try and do a little lot of announcer voices now. 0.051. 640. I'm going to do my little presenter voice. 0.052. 640. like a computer or something, I guess. 0.052640. It's a bit weird. I might stop it. 0.053700. What one are we on now? God, I'm getting confused. 7778. Yeah, I'm with Julian on the not finishing projects thing. I do it all the time. In fact, Sion released a video, The Unexpected Maker, if you don't know who I'm talking about when I say Sion. Just give him a Google or look on Twitter or whatever. He's an Aussie maker. He's a really nice chap. He's not got a lot of content out at the moment, but he's putting out content all the time. Used to be a game developer, I think, so he's really good at coding. So go and give him a wave, say hi or whatever on his stream. But yeah, well worth watching. He's doing some stuff with NeoPixels at the moment as well. And he's very charming. And that's one of my favourite things about people on YouTube. If they're charming, then I watch. If they've got a good voice, because it's mostly about the voice for me. 0.054700. I can't, do you know, I used to listen to the, sorry, I'm just sort of reading something that Simon said. It popped into my head. Simon said, shipping forecast style, please. God, didn't you just love listening to the shipping forecast? When I was a kid, we used to have it on. It was great. My dad, when was it on? I can't remember. Was it on late at night or early in the morning? My dad used to drive trains, so steam trains. Not for a living, but as a hobby. And we used to go down with him in the morning. And we'd have to leave at like 4 in the morning or something ridiculous. And I'd go to sleep in my clothes at 4 in the morning, and then my dad would like pick us up out of bed and put us in the car. We'd be asleep, and then we'd get to this. Was the Neen Valley Railway, and God, it's always, the streams always end like this, don't they? Or end up being this, where I just tell you about my life or something. I don't know what to make this. I'm going to make it 0.054 again. Yeah, we used to go on those steam trains, and on he'd be on the footplate. He was a fireman. So that's the guy that feeds the coal fire thing. And I vividly remember either listening to the shipping forecast at night before we went, or on the way there. I can't really remember, but God, I used to love it. I've ignored chat again now because I've been chatting. Sorry. Incidentally, they had a Thomas at the Neen Valley Railway, and I think I saw the Flying Scotsman, or was it the Mallard? If you don't know trains, those are two very famous trains. The Mallard was this cool blue one, as far as I recall, and the Flying Scotsman is green. I mean, and also rounded, whereas the Mallard, I think, was the fastest train at the time, like 120 miles an hour or something ridiculous. I'm not a train spotter by any means, but I thought they were cool at the time when I was a kid, and still do. They are cool. Oops. I added extra 0 on that one. Oh God, Dogger, I remember. And something Bank, Jodrell Bank, is that right? No, that's a telescope place, isn't it? I don't know. Dave says, I'll hop over to Sion now. Good luck with the numbers. Here's Sion's live stream. Oh, thanks, mate. In fact, I'm just going to... Hang on a minute. I'm just going to post a little note to Sion. Hang on a minute. There we go. I don't know what I was saying now. Colin's asking Julian about his PWM5. I'm really excited by that, about your foray into SMD sort of design. I'm interested to see. You always investigate things much more cleanly and thoroughly than I do. So I'm sure you will come up with some really good ideas about how to achieve good results. Are we still on 700? I don't want to jump the gun here. No, we're not. I am jumping the gun. 740. God, I don't know if I'm ever going to get through this. We're only doing one, remember. So we're fine. So 0.057, 740. So I should probably tell you about other things I've got coming down the pike. That's not an expression I ever use, but it turns out I've just used it. 0.057 and 740. Ooh. Next one. 0.058, 740. Unexpected measure. Is happy to probe. Rewind your way. He's just said he'll postpone. What an idiot. He's not doing that. Not a chance. Julian, are you going to do any more live streams? Just wondering. Oh, God, I put 6.8. Did anyone notice that? No one noticed. Let's not just imagine no one noticed that. 8.6. We're on 8.7. We're on 740 still. 0.058. 740. This is going to be one of these streams where at the end we realise there was no point doing a stream. Next one. Because nothing happened. 0.059. 740. Yeah, I'll tell you what I've got coming up, coming down the pike, as it were. Well, these binary clocks, I've got two, one for me and one for a mate at work who soldered one together himself. Did he heck? He did it in one of those oven things. So he cheated. I did it by hand. So there we go. Anyway, he also chose one color of LED, and I chose sort of the pink because, you know, pink's cool, isn't it? And I sent him a picture of the 3D printed thing. He was absolutely stoked. So I was very happy about that. I thought that was pretty good. So he's really, really pleased with the 3D printed like box it's going to go in. He didn't expect that, which is nice. So I am glad. All right, I jumped up to 800 now. And so I'm going to finish those off, release the design files. So that's the schematic and the PCB layout. 0.06, 0, and 800. And also my sort of bare bones code, which just pulls the temperature off the DS3231. It also pulls the time off the date, allows you to set the time and change the mode of the display and whatever, and does all that stuff. What's going on? Sion is feeling really guilty now, bless him. Oh, can someone go over and explain to him that I don't want him to feel guilty about it? I set my stream up with 15 minutes before it was meant to go live, so I didn't know he was streaming, so it's my fault. And we're not taking, like, you all come to watch me fail. You go and watch Sion to see him succeed. It's totally different. Anyway, are we on 91? We're halfway there. No, we're not even halfway there. We're maybe halfway. Not even halfway. So we're on 91. Are we? Yeah. 0.06, and we still on 800? We are. Still on 800, 0.061. It's entirely possible this lux meter has a different resolution the higher it goes, so it might have a reduced resolution. Julian says he really wants to use your phone. Is that for streaming? You need a better PC. Well, Colin says he's got a spare i5 system. My system's an i5. I edit 4K video on it. It's perfect. It's an i5 3570K. It has a graphics card in there as well, though. But yeah, it's great for streaming. Works really well. I'm looking to upgrade it as well soon. Soon, probably at the end of the year. Thomas C says, can I have advice? You can indeed. There's a lot of very knowledgeable people in the chat here. So although I mean, it was at 65. It's now at 50. So I think people have realized this isn't going to be some kind of, actually, I'm not doing a spreadsheet stream, but it's really I'm doing a spreadsheet stream and also getting slightly drunk doing it. In fact, I'm going to go and grab another beer in a minute. God, it's 10 o'clock at night. So this stream ends in 40 minutes now. So I don't know if I pick up the pace, do you reckon we'll get there? Oh, that's wrong. Oh dear, one beer and I'm tipsy. That is outrageous. 0.061. Right, next one. Pick up the pace, David. Let's get this one done. 0.062. 800. Oh, also, I did want to ask, since I've got a few of you here, 48 now. Okay, a lot of people disappearing. But while I've got you here, do you remember the binary clock thing? All right, I was going to use a couple of kits for giveaways. Well, I've got to the point now where they're ready to go, basically. And I need to put them on a shop, on a store. It's going to be on Tindy, I think it's called. Well, if anyone's got any ideas for swaps, if you use Twitter, that is probably the best place to send me a swap request. And then I'll do a little voting thing where I'll let everyone vote for the swap that I should go for. But it basically means you send me a kit and I'll send you mine. But yours can be anything. It could be something you've made. It could be even a board that you've made. So I don't care if I don't have to solder. It could be something you've stuck on VeraBoard that does something interesting. It could be your very first 555 timer with multiple outputs, or it could be, I don't know, your an intervalometer you created or something. It could be anything. But I want to be able to do a little video on it and say, this is something that someone sent me. Aren't they cool? Here's their YouTube channel, or this is how they made it, and here's the schematic, or I'll remake whatever you made. You know, something fun, because these will retail. It's weird to say that, but it's like 10 quid. So I'm not looking to make money back off the swap. You could send me something that's worth £1. I don't really care, or something you made yourself and it doesn't really have a value. And do you know, if you just want to send it for me to look at and investigate, maybe copy the schematic or whatever, and you want it back, let me know. If it's something close to your heart, then I can return it. Why didn't that? Oh, there we go. But tweet me and we'll do it. Look at this. That's what drinking Sadler's Hot Bomb will get you. That offer goes out to anybody, no matter if you're on YouTube or not, by the way. So I have 2 to give away at the moment. It may be more than that. I might make it 4. I don't know yet. I haven't approached Tindy to open a store or anything yet, so I don't quite know how all that works. I was rewatching some of my old videos the other day, and I did that because Sion had posted this video about procrastination. You should go and watch it. It's really honest. It's nice. It's sort of like one of those heartstring tugger videos. He'll probably forgive me for saying that, hopefully. But you know, it's like a self-reflectance thing. And I've been chatting to him about it, and I remember I did something about 5 years ago called something about failure. I can't remember the title of the video, but I was like a child then. Like, looking at myself now, I feel I look a lot older. Although I spoke to one of my mates the other day and they said that I haven't changed a bit. But I think I look a lot older. But the audio is terrible in that video. But I was a different personality, I think. It's odd looking back at yourself, certainly in video, which is something we can strangely do these days. It's not... there's a video of me when I was a kid, when I was 5 years old. Hang on, it was 1994, so actually I wasn't 5. I was 7 years old. Is that right? I was born 83, 4... I'm not quite sure. I can't do maths. But yeah, I think it was about 7. And it was really weird to see myself on video at 7. But kids these days are going to have that throughout their entire life, aren't they? Anyway, I was looking at my old videos and I thought, wow, I've really changed the way I approach electronics. I don't know whether I've matured or become a bit more confident in what I'm doing, or whether it is I make less mistakes or make more. I don't know. I think I've got this bit of a reputation now for being the guy that messes things up or lets magic smoke out or, makes a terrible mistake. And largely I suppose that is true. It's justified. But I don't think it's always the case, is it? I don't know. Someone will have to tell me. Chris says, remember the cheap PC you got the other day, 22-inch monitor? Well, that is a pretty decent machine. Dave Darko says he'd be game for that. Cool. Well, if you tweet me, let's do a hashtag, shall we? Binary swap. No one's going to be using that, are they? So do a hashtag binary swap, and you can either tweet it at me or I'll just look for that hashtag, whatever. But then we can collate the sort of responses. Neffa says he's hoping to visit the Railway Museum in York again this year. It's an awesome place. Chipped a few quid into the Flying Scotsman rebuild. Are they rebuilding it? I didn't know it was broken or anything. I thought it was all right. Let's hang on. I'm not sure if I'm on the chat. Hang on, I've just jumped onto Sion stream and Julian seems to be cheating on me with Sion. So there is that. I'm fine with that. I really am. 0.066. What? Oh God, wait. Dave Darko, is binary swap something rude? Oh God. Okay. How about... Oh, I don't know. You choose something. I don't know what binary swap would mean. It might be perfectly innocent. .066 and what it's... I mean, I did say I don't blame anyone for jumping over the stream. Seriously, you could leave me on my own. I'm still going to do this. I've got to do it on my own. You just get to listen to me ramble and semi-perform for you guys. In fact, the stream's going to go dark for a second because I'm going to go and get another beer. So I will be back shortly. Is there a... There's nothing in there now. I'll be back in a minute. Right, well, I picked up something different. It is called a Franziskaner, or I'd be a Franciscan monk, I guess. Weissbier. Premium Weissbier, natural rub. I can't remember what U with the umlauts over it is. So this one is it's like a wheat beer, isn't it? But I don't know much about it. So Julian got busted. There are 2 teats related to cis and gender swap. Okay. Well, we'll just use a different one. How about David Watts swap? Just do that. Julian says you're quite self-deprecating. I know, I am. It's so no one else has to do it for me. So let's carry on. I think if you were bullied a lot as a kid, I think you generally are self-deprecating. I'm not sure I entirely was overly bullied when I was a kid. It certainly wasn't not bullied, but that's just the way it is, isn't it? Next up, 0.068 and 900. I do the same thing, Julian, don't worry. I wasn't actually getting all jealous or anything. In fact, I've got enough people that watch my videos now. I'm perfectly happy if everyone goes over and watches Sions for a bit. Honestly, the pressure is is enough over here. Especially, what am I on now? Especially since I've had one beer, which was like 5%. And now I'm drinking another one, which is... And these are 500 millilitres, so it's like a pint or more. This is 5%. So this Weiss bit, we should probably just have a bit more of it. It's really nice. Do you know why I bought this? Because I thought it would be like Leffe, which is one of my favourite beers. And I tried to find one called Leffe Brun, which is Leffe Brown in German, or Belgium. It's Belgish. Belgish? I don't know. Whatever. What are we on? 0.1, so 70069 900. Next one, probably 0.070. Yeah, and it's probably gone up, hasn't it? No, we're still at 900. So either the resolution goes down on this lux meter, then either it goes down on this lux meter at higher levels, or it's not giving us that much of a range. Electronas says David Watt swap could have its own connotations. Well, I don't mind if anyone takes any connotations into mind. Hefeweizen, is that what this is? Might be that. Is very nice in the summer. Unfiltered wheat beer. Which probably means it's going to give me a hangover, but who knows? Let's go for David Watt's swap then. Let's do that. So, 108. Let's go 109. Let's get this finished. We've got 25 minutes-ish before I should really stop and go to bed. Or chill out for a minute and then go to bed because I've got to go to work tomorrow. 900. We can do this. It's only it's only trying to get all of this stream into a tiny amount of time. 0.071. 900. Next one. 970. Look at that jump. That's incredible. So 0.071 still and 970. Let's just check on the com output. 111. Yeah. Okay. 0.072 970. Next up, 0.072 870. Don't read things out, David. You're an idiot. Yeah, so anyway, I was talking about what was coming up, and then I decided I needed to go and get a beer, like some kind of alcoholic. But what I've got coming up is the binary clock selling. So I'll do a little video of that, probably a build video, which I've already recorded and uploaded, but not released because I thought it was a bad idea to release it without selling the damn thing. If I'm honest, I don't really want to even sell it anymore. Because I've already paid, it was like it's about £200 or something, a little bit more than that, probably 220, 230 to pay for all of the components of the board. And now I've paid that months ago. I don't really feel like I'm out of pocket, so never mind. I've got to sell them really. It's no point making these kits. I'll never do it again if I don't sell them and get the money back to fund the next thing. But yeah, I've got those, the crap clock, which I can't wait to release. You know, I'm really excited about seeing other people potentially make something that's the same. I've got one board somewhere. I had a board somewhere. You are, oh, there we are. So I've got one board left, one of these left. That's probably in focus if I throw it down there for a minute. Yeah, I've got one of these left. So when I go to release everything, I might give it away. So I've got one that works, so I'm fine using mine, but someone else might want one to make. But it does involve buying all the components, and it's a heavy component board. There's a lot of LEDs on there. There's a lot of sort of other passives. You've got the ATmega 328P-PU and -AU, sorry. You've got the TLC 5940. You've got a 748C 595. If you wanted to go the whole hog, then you can put a Max 1811 on there, which is the lithium-ion charging chip, which is the only one I used at the time. But there are loads around now, like in SOT 223 packages. But I used a SOIC 8 one, or SOIC 8 or whatever it is. SOP 8 it might be. Anyway, what are we on? God. 114. What else? Oh, crap critters. Oh God, I love these things. I've lost a bit of paper. I don't know where it is. It's somewhere around, but I've been drawing crap critters, which I love doing, you know. They're essentially like children's drawings, because that's the level I'm at with drawing. And then I just make sure I can shove some kind of microcontroller on it, or some kind of IC or electronics. So one of them is a crap critter cricket. Can't speak. Crap critter cricket. And what it does is it makes a cricket sound. It won't sound anything like a cricket, probably. It sort of sounds maybe similar to a cricket you might hear in a computer game at the moment, but it's on a breadboard somewhere. Where is it? It's on this desk somewhere or other, or I've taken it apart. I don't know. You around here? No, I've lost it. Or have I completely taken it to pieces? Oh, heaven knows. Anyway, so that's around, but there's also the crap critter Firefly. So that's going to be 3 SMD LEDs, green ones, on the bum of a crap Firefly that I've drawn. Oh, here you go. Look. There it is. Let me see if you can see this. Ugh. Can I shield that some way? Hang on a minute. We'll cheat. You can see it on this camera instead. So I've designed it all up. Designed my circuit, labeled everything. So that's what it's going to be. So that's the crap critter Firefly. So those things, it's basically, they're going to run off 2032s, or is it 2032s? Those little batteries, and then they'll run for like a year potentially on one battery, and they'll go off every 10 minutes or whatever, and then go into deep sleep mode. So that's sort of the idea. And they're going to be easy to solder through hole components, and so like something like beginner friendly, I guess. It's at 970 at the moment, but it's sort of flickering between 0.073 and 7.4. I saw a flicker, so I think this time it's going to go up because it's been 970 for a while. No, still 970. 0.074. If you'll notice, I'm adding crap onto everything these days. But yeah, that's the new thing, essentially. It's circuits with what are they? The 80 Tiny 85 running off a single 2032. Or maybe two, I'm not sure. We'll see if it can run off 3.3 volts or it needs 5. What one are we on? 116, next one. Still 970, 0.075. 970. How are you still 970? 0.075. 970. You've been 970 for a long time now. Okay. 0.076. 970. I don't see it really changing, but it... Oh, now we're on 1000. 0.076. 1000. So there have been some interesting jumps here from 900 to 970, 970 to 1000, but there are, it looks fairly linear. I mean, just like the previous LED that I looked at, the increases here are tens. You get a lot in the very first point of like loading this LED, and then they're slowly increasing as you go up, but it looks to be not so far off fairly linear, which is quite disappointing. So yeah, we've got the crap critters. That's what I'm sort of looking at doing next in terms of circuit board design. But there's loads of things that I've dropped recently. Leonid said, are you using 3.3 volts or 5 volt for LEDs? I'll be using 3.3 volts. They're going to be fairly dim, but it's not meant to be super bright or super loud for the buzzer. Steve Johnson says hello. Hello. Is Sion still going? He is, probably, I imagine. Right. We need to get a move on. Let's try and blitz a few of these. Julian, you can bugger off. 0.077 1000. Oh. And then we've got next one. 0.078 1000. 0.078 1000. Do you know, I've just realised that someone probably could use this and fake a bank call, one of those telephone banking things with my voice. 0.079 1000. .079. Actually, what number are we on? Making sure. Yep. 1000. Brain freeze is here. Hello. Did I press the button? No. 0.079 1000. 0.080 1000. Next one. DIY in the ghetto. I don't know if we've talked before. Hello. It's going well, thank you. We're just doing some really pointless tests of an LED. 0.081 1000. That's 100 1000. 0.082 110. No, one, whatever. God damn it. Well, this was a brilliant way to spend an evening. I'm not flagging or anything. He says. Oh, God. Come on now. 0.082 100. Right, what's next? Zero point zero eight three 1100. 0.083 1100. Oh, it's minus 0.083. Oh, is it 4? Yeah, it's 4. 0.084. Oh. Electron says, oh, you were Joseph. Hello, Joseph. I remember you. If this was an EV stream, he would have used fancy parts, test gear to do this automatically. I don't even have a decent oscilloscope. Yeah, he probably would have done you all right. And then slagged it off the whole time. But he's very entertaining doing that. 135. 0.084. 100. Still the same, 0.085. 0.085. Seems fairly linear so far, guys. No. Oh dear. Oh. I hope you feel sorry for me. Oh, we're at... It said 1200 there for a second. Maybe it's a little bit of reflect. What? Turned off. Does it need new batteries? Oh, it needs new batteries. I'll just go and get some. Oh no, I've got some down there. Yes, I do. These are rechargeable though, batteries, so I don't know if that's going to make a big difference. Oh, that's disconcerting. The batteries go in the same way. I don't think I like that very much. It just means if I put them both in the wrong way, then something's gone wrong. There we go, we're back on. Let's just test that again. 100. Yeah, we're fine. 0.087 100. Step. Now we're at 1200. 0.087 still. 1200. So it's just tipped it over. 0.088 1200. 0.088 1200. 0.089 1200. 0.0891,200. Just check we're on the right one so I don't mess it up. Yeah, we are. 0.0901,200. 0.090. That's a 9. Yeah. 1,200. We're going to get to 180 guys soon, so just get excited for that, if you know what I mean. 0.091. 1,200. 0.091. 1,200. Julian, the DMM, the batteries seem to last forever in this thing. Yeah. I don't know why. I don't even know what kind of... I can't remember the battery that I put in there, but it has not failed me in years. I remember when I moved into this house, I haven't replaced the battery since. So that's 3 years since I've been here. And before that, I lived in a horrible flat, which was awful. Where are we at? It was so loud all the time. So if you look like 3 years ago, you'll be able to see some terrible, terrible video that I did with really bad audio. 0.092, 1,200. Oh, we're on 1,300 now. 0.092. 13. Whoops, a daisy. Let's correct that. I really should turn my phone off when I do these things. But let's have a look what people are saying. It's Twitter interactions. Oops, I pressed a button. Oh, Dave's doing his offer. That's good. I don't know. I'll get rid of that because it's rude, isn't it? It's just impolite. We're not even almost there. We're 100 away. And it was meant to finish in 3 minutes' time. All right, we'll go to 11 and then we're going to stop. Because it's been so interesting so far. What? Okay, it hasn't, I know. But let's not worry about it too much. It's been a stream. And every stream is better than the last. We've probably made more progress in the last 40 minutes than we did the whole of the previous bit. I think I'm just going to, just so I can look at this burden voltage, I'm just going to measure the voltage that's getting to this board. I'm just going to get in the way and maybe short everything. Who knows? So getting to that board is 4.62, which is, that's 20 millivolts less than the previous test. I don't know why. At this point, I measured it at 150 on the last one. So maybe my power supply has dipped a little bit. So perhaps I should look at changing that. You want to see the chart? Well, it won't really have a good scale at the moment because this is the current chart that we have. But because it's got these two scales, you won't see what the final one is for the lux. So at the moment, it looks like they're deviating greatly, but they may not in actuality. Julian asks, how's your noisy neighbour? Well, my neighbours aren't very noisy. I'm probably being the noisy one right now. But they do sing quite a bit. And there used to be a guy that lived next door. I don't know why I'm whispering. There used to be a guy that lived next door who'd play guitar quite loudly. And he was really good. Like, he was great at guitar. But quite loud when I was trying to record on a Sunday. And it was a bit annoying. And so yeah, one side sings. They've got 2 kids, and the other side, I don't know. Sometimes it sounds like they've got 5 kids. I'm pretty sure it's less, but they do shout a lot. But I'd rather have families than some people that like work nights and play loud drum and bass music or whatever. Simon says, any ideas on a sweet spot yet? I still think basically the middle is pretty good, or throwing in as much current as you can, and actually you're getting more bang for your current buck, as it were. But the lower end doesn't seem to be great, honestly. 153. I'll know when we get to the last one of these graphs, and I'm going to make some assumptions about the last LED that's in there. 0.094. Do you like how I just speak and then just go straight for the numbers? I mean, it's safe to say, Steve, that I haven't really been, Simon, safe to say that I haven't really been on this. I think we've been chatting quite a lot, all of us, rather than doing work, which I should have been. 0.096. 1300. Oh. I'm going to have to borrow this thing again, aren't I? Where are we at? 157? Yeah. 0.096. 1300. 97. 1300. Hey, Kev's Electrical Workshop is here. That's a very descriptive name. Hello. So 0.097 1300. 0.098 1300. 0.099 98 1300. It's going to go up now though. Oops. Yeah, 0.099 1400. So the resolution's changed on this lux meter, I think, at these high levels. 0.099 still. 1400. It's jumping up to the 100 milliamp bit. So 0.1 1400. That's going to be easy on the typing. 0.1 1400. Also, the resolution on this meter is going to change. It is 0.01 actually. I'm going to... Well, it's bouncing around. That's in the milliamps range. If I switch it back to the amps range, we get a different reading, which is, again, not agreeing with my power supply, but, you know, that's what will happen if... So at the amps range, at these higher milliamps ranges, it actually has... the burden voltage is lower, so actually you get a more normal current reading. But in the milliamps range, you get higher precision at lower current draws. So if I were to then switch to the milliamps range into the amps range, we get something that's slightly closer to my power supply. Because the milliamps reading at 100 milliamps is reading 20 milliamps out from my power supply because of the burden voltage, which is frustrating. But we'll continue with the readings that we have. So what's the one we got? 165. We need 166. Steven says it's more interesting watching paint dry. I've never tried, but it probably is marginally more interesting. Julian, you should definitely upload a video. Give other people something to watch who don't want to watch this. 1400. And then next one. We've got to make it. We can do it. Shit, it's almost 11. I mean, sugar, it's almost 11. 0.102. 1400. I mean, it's ultimately a waste of time. 0.102. 1400. 0.103. 1400. 0.103. 1.13. Yeah, 1,400. 0.104, 1,400. 0.104, 1,400. Oh, sugars. 0.105, 1,400. Okay, 0.105, 1,500. 500. 0.106, 1,500. 0.106, 1,500. 0.107, 1,500. 0.1, no, 0. Whoops. 0.108, 1,500. Oops. 0.1008, 1,500. I'm flying through now, aren't I? Amazing. 0.1109, 1,500. 0.109 still, 1,500. 0.110, 1,500. Just gonna have to have a bit more beer, jeez. Oh. It takes its toll. It really does take its toll on you. Come on, David, just get it done. Jeez. Where are we at? 182, 183. I'm surprised that I've managed to keep these accurate-ish. 0.111, 1,500. 0.111, 1,500. 500. Type it. 0.111, 1,500. 0.112, 1,500. 0.112, 1,500. 0.113, 1,500. 0.114, 1,600. Simon's on his second drinking chocolate. Slow down, man. Jeez. You renegade. Oh no, 0.1414. Oh god, I've lost my rhythm. 1,600. Let's go. We can do this. We can do it. Oh, sugars. We can do it. We're almost there. Come on. 0.115, 1,600. 0.115, 1,600. 0.116, 1,600. 0.116, 1,600. 0.117, 1,600. 0.117, 1,600. 0.118, 1,600. 0.118, 1,600. We're getting there. We're getting there. 0.119, 1,600. 0.1600. No, what? Oh. Okay. 0.120, 1,600. 0.120 1600. 0.121 1700. Oh. 0.121. God, Julie, I'm losing it. How did you get through those LEDs? 0.121 1700. 0.122 1700. 0.122 1700. 0.123 1700. 0.123 1700. 0.124 1700. Said it like a question there, bit American. 0.124 1700. That's not a zero. There we go. 0.125 1700. I think it's probably going to jump now to 1800. We've had 1700 a lot. Not yet, it's not. 0.125 1700. 0.126 1700. I don't know if any of you can tell, but I'm starting to flag a little bit now. But you know, lots of people have left as well, so it's not just me. How long have we been going for? 2 hours of doing this. Holy moly. Okay. 0.126. What number are we on? Have I got it wrong? Yeah. No, 213. 0.126 1700. You know, if this was April 1st, you might believe it. 0.127 1700. At least someone hasn't pointed out any kind of mammoth mistakes in my methodology. Don't. That's not the time for it now. 128 1700. 0.128 1800. 0.129 1800. 0.129 1800. 0.1130 1800. 0.130 1800. 0.131 1800. 0.131 800. 0.132 1800. 0.133 1800. What's 1900? Well done, David, for jumping the gun. We're almost there. 0.133 1800. Whoops. Oh, for heaven's sake. Sorry, mistyped a little bit there. Sorry about that. What are we on? 226. 0.134 1800. Next one. 0.134 1800. That's because I pressed tab, isn't it? Next one. 0.135. 134, 135, again 135. And that is 1800. If I had a more accurate multimeter, or one that was in a more accurate mode. At the moment it's in the milliamps range. It might be better. What are we on? 228. Okay, one more button press. Okay, just need a little bit more beer. I'm tired. And also that beer's gone to my head a little bit. Don't tell anyone. We're almost there. I can't believe it's taken so long. Is Sion still going? Anyone know? I'll go and join his stream after I'm done with this thing. How long have we been streaming for? Does anyone know? I haven't got a clue. 229, okay. 0.135. One 800. Next. 0.136. 1/800. 0.1336. 1/800. I don't know why, but this is 0.137, so we've jumped up, and this will gives an increase 1/900. 0.137 still. So I think we're going at this point later in the graph. We go up by sort of half a milliamp, I think, every time. And this is going to be that 0.0137, 1/900, and then it's going to be 138. Yeah, 0.138, still 1/900. Zero 0.138, 1/900. We're almost there. Oh god, I'm really sorry I've made you watch all of this. Where are we even at? Like, how many people are even watching this crap now? I don't know how to tell. I have no idea. A lot less of you than when you started, I'm pretty sure. You'll never be coming back to a live stream ever again. What number are we on? 236. 0.139. 1/900. 0.139, 1/900. 0.140, 1/900. 0.141, 1/900. Julian asks, is that 138 milliamps? Yes, it is 138 milliamps. So it's 0.1 of an amp, or 0.138 of an amp. 0.141, what are we on? 240. 0.141. 1/900. I'm just hoping they're going to stay cool. There's quite a lot of them. So that, if you have a look at this board, that 140 milliamps is shared across 4. All right, okay, don't judge me here, but I cannot do maths. So I'm going to have to count these individually or in groups. 2, 8. It's shared across 16 LEDs. So actually it's not an awful lot. It's like, like 5 milliamps each. Is that right? Times 16. I'm going to have to use the calculator. Hang on a minute. What was the number? 138 divided by 16. Yeah, so it's like 10 milliamps each. It's not a lot. So there are 16 milliamps per board, 16 LEDs per board. Kev says with beer. Thalos. I'm going to guess that's Thailandos 9944. Hello. You're absolutely right. I have it in a spreadsheet, don't I? I can look it up or use the calculator in here. We're almost done. We'll be there. We'll be finished in a second, and we'll quickly take a look at the graphs before I end the stream and go and sort myself out to go to bed. All right, are we on 241? No. Now we're on 241. 0.142. $1,900. What's gone on here? That should be C42, shouldn't it? What? Hang on a minute. There we go, 1,900. 0.142, 1,900. I'm almost finished. Almost. 0.142, 1,900. 0.143, 1,900. 0.143, 1,900. 0.144, 1,900. 0.144, 1,900. 0.145, 1,900. Oh, I forgot to do the 180 thing from the darts. I forgot to do that. 0.145, 1,900. Let's check that was right. 148, yeah. 0.146, there we go. It sounded like a broken robot there, didn't it? 46. And now we're on 2000. So 147, 0.147, 2000. 0.147, 2000. 0.148, 2000. 0.14825, 2000. 0.149, 2000. There it is. The brightest this darn thing will go. 255. 0.150, 2000. So that means our cumulative brightness increase has been 1,940. Okay. Oh dear. Right. So what do I need to do? Equals 1940 divided by 255 equals 7.607. That's fine. Let's do that. So linear current increase equals 0. Paste the value only. And then we're going to bring all the way down here. So this gives us the linear increase per step. If it were linear, which it might be. I'm not sure. Oh, God, don't go. Oh! Okay, we won't go all the way to the bottom. Hang on. Okay, there we go. So that's if it were linear. And then this end column is if it was divided by 16. So per LED. So at the very end, we were looking at... Ooh, is that divided by 16? It says B. Pretty sure it should be... Oh yeah, that is right. Why is it... I don't know. 9 milliamps, is that? Yeah, that's 9 milliamps per LED at the top end. That's cool. Now, the linear lux increase we need to look at. So that is cumulative lux divided by 255, isn't it? So equals... what is it? Equals 240. 1940. 1940 divided by 255. God, that's strangely exactly the same as the frickin' current, isn't it? God. It's just basically the same. Per step lux increase is basically the same as the per step current increase. There might still be a spot. This is just averaged out, so there might still be a sweet spot. Don't you start, Julian, or I'm going to ban you from the... Oh, God. Let's paste that in. Paste in the value only, and that's 0. I mean, look, it's so close to being exactly this. Is it exactly the same? Have I done something wrong there? Hang on a minute. Oh, I did. I might have done the calculation wrong, everyone. It should be. Oh, God. Okay. I sort of did it wrong. The reason it's exact is because I put the wrong numbers in because I'm no good at calculations. Equals 0.150 divided by 255. That's my current number. And I put my lux increase number into the current number because I'm an idiot. So that's linear current increase. We need to put that number in there. Paste values only. And then we increase it. No wonder it looked perfectly linear. Idiot. Oh, well. There we go. We've got that one. I should have just copied and pasted that column over, actually, now thinking about it. Never mind. And then bring this down. Stop. 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 Okay. That is... Right, so what did we want to look at? So there's our brightness versus lux. Let's just check it's using the right data. We're using A, that's correct. And then on C, we want to use C. Okay. Yeah. So not quite linear, but fairly close. And this is our log graph. So it sort of gives us an idea of the ratios a bit better. So again, more of a... Well, there's less in the end, really, there. This is our... Let's see the data on this one. Just change that. Get rid of A. Add another range in and get rid of that. And then put A. Add another range to F. Okay. Yeah. It's about as revealing as the last one, if I'm honest. It's sort of linear. It's not quite. It looks like you get less of a return in the initial stages. And then in the middle looks like the sweet spot, really. So that's it. I'm done now. Let's call it a night, shall we? Well, Leonard said it's just because of PWM, but PWM will turn that thingy on and off like perfectly fine. And so it sort of averages out the current draw a little bit. But brightness is not related to the current draw, not necessarily. So most LEDs, you get a massive gain in the first portion. It doesn't seem that that's what we get here, but we get a large gain in the end portion of the LED, the end part of the PWM. So it could be that, I don't know really, maybe it's the duty cycle of that PWM, I'm not sure. Like it can go off 255 times a second, but how long is it on for in that time? Like, is it, I don't know. I don't know. Anyway, I give up. This was a silly idea. I will test the other ones just to be sure, but it's largely linear. There is a bit in it, not a lot. You can see there's a little bit in it, but not a lot. So I don't think there's going to be much to gain here from, I mean, you can see this one's largely similar to this one. Look, we can, if I make both these roughly the same size. So these are the two readings that I've taken from two different LEDs. So we can see the lux here and the current here. And you can see there's a larger portion here where we're gaining something. So this mid portion, we're gaining quite a lot. And the end portions, we're not gaining quite so much. And that's largely the same here, except for perhaps less pronounced. So, yeah, basically, anywhere in the middle, you're all right, it turns out. Okay, well, I think we should call it a night. I'm going to say goodbye now. So, thank you very much for joining me. And we will speak again on the next stream. I'm not sure when that's going to be or what I'm going to get up to, but thanks a lot for coming. It was really nice to have some people to hang out while I did this, and it absolutely took a lot longer doing a stream testing this than it would do if I wasn't doing the stream, so you're welcome. No, it's fine. It was nice to hang out with you all, and I shall, we might do a little video on this if I find there's anything really to tell other than it's perfectly linear, or it might as well be linear, then I'll do a video, but I'll tweet about it anyway. All right. I'll just check, make sure there are no massive questions. No, probably not. Shut up, Julian. There might be a sweet spot. Stop harshing my buzz. I'm kidding. Right, night everyone, and I'll see you next time. Take care.